Okay, welcome to the NUPOC Video Study Guide number 39. We're going to look at question 2 in the calculus section of Guide 1, which asks us for three things. It asks us to show the ability to integrate or differentiate by the following methods. So, integration by parts, chain rule, and the division rule, or the quotient rule. So let's go ahead and do integration by parts first, and let's just make it its own video because it's going to take a little bit longer than the other two examples. Okay. Excuse me. Okay, so what we have here is a function that we're going to integrate. That's a good candidate for integration by parts. It's the product of two factors here, each of them dependent on x, and both of them, and we can split this integral up by using integration by parts. We can make it a lot simpler by using integration by parts, right? So we can relate this integral to this form over here. It's the integral of sum u times sum dv. So let's go ahead and start by choosing what our u is going to be. I'm sure most of you recognize this, right? This is a good LIAT is a good device or a good memory aid to remember what you should choose as u. You want to choose things for u that are going to become simpler when you differentiate them, and you want to choose things for v that aren't going to become any more complicated when you take their integral. So you want to choose, if we look at this, what would become, well, I guess not any more complicated if we took the derivative, and certainly there's one that's not going to become any more complicated at all if we take the integral, right? And that's the exponential, so exponential should probably be the dv, and our trig function will be our u. Now, as you go up this scale here towards, this is the start of it here, right? Logarithmic and inverse trig and stuff. It becomes much simpler. The u, taking the derivative of it, and that sort of thing. When you get down here, not much is going to change, right? I mean, if you have an exponential, it doesn't really become any simpler if you take the derivative of it. Now, a trig function, same thing. It just flips back and forth between different trig functions, so it's not like it becomes dramatically simpler. But at least it won't become any more complicated. So let's just go ahead and do this. So let's say u equals cosine of x, right? And dv equals e to the x dx, right? So that way we can apply this integration by parts rule here, right? Integral of u dv equals u times v minus the integral of v du. So let's look at what our du will be, right? So if we take the derivative of both sides here, right, d du, this is going to end up being, and we have d dx here, right? So our du is going to be, let's see, minus, or excuse me, sine, positive sign, since our slope, or negative sign, since our slope is going to be negative on a cosine, right? So this will be negative sine of x dx, right? And our v, just integrate this, this is just going to be e to the x, right? Okay. So now we have u times v, right? So e to the x cosine of x minus integral of v du. So e to the x, I'm going to bring out this negative sign here, right? Sine of x dx. So this is equal to our original function, but now we have this other function here, and it looks like we should use integration by parts here, so let's kind of do the same thing. Let's choose u equals sine of x, and so our du will equal cosine x dx, and we'll choose a dv to be e to the x dx. So our v is just e to the x. So now let's take this whole term here and apply the integration by parts formula a second time. So for this, we will have u times v again, so e to the x sine of x, right? Minus v du, right? So v e to the x du cosine x dx, right? And so this integral is the exact same thing of what we had in our original function. So let's add this term in that we got from the first integration by parts, e to the x cosine of x, right? Add that, and this is all equal to our original function, e to the x cosine of x dx. And you might say, well, this is kind of frustrating because now we have the same function we started with, the same integral we started with, and now we're going to have to just keep going in circles and doing this all over. But there's an easier way to do this. When you end up in this kind of situation, you just take this integral, just move it to the other side. Excuse me. So adding this whole integral to both sides of the equation, we will get 2 integral e to the x cosine of x dx, right, equals e to the x cosine x plus e to the x sine of x, right? So at the end of the whole process of doing integration by parts twice, we'll have our integral, our original integral, e to the x cosine x dx equals, bring this to the other side, this will be e to the x over 2 cosine x plus sine x. So there we go. A nice demonstration of using integration by parts, in fact using integration by parts twice, to get our answer to this integral.